Hi everyone, this is my lab report for lab 3 circuits. The purposes for this lab would be to predict the behaviors of circuits and to use some multimeters to measure the values in our circuit and examine some behaviors of resistors and capacitors. Some fundamental physics principles that I use is Ohm's law and the formula for capacitance, the loop rule, and the node rule. Some brief preview of results I've got is that the current of the first circuit we built in our experiment is 0.02 amps, and I measured some values of voltage and currents in some experiments, and also the RC of our final circuit is around 7 seconds. The experiment setup, we used CCK to build some circuits. So the first experiment, we hooked up this circuit, and we predicted the current to be 0.0204 amps, and which matches the actual measured current. If the emitter is reversed, the value will be negative because the current would be flowing the other direction. In experiment 2, we changed the emitter to a voltmeter, and here are the predicted values. Since the voltmeter has a resistance of infinity, thus there would be no current. In experiment 3, we used the voltmeter to measure the potential differences, and these are the values I got. Summing up all of them, we got 0, and that matches with the loop rule. The current is measured as 0.02 amps. In experiment 3, I drew this graph as well. And some questions. The ammeter reading, why doesn't it change? Because the simulation gives the ammeter 0 resistance, and when I connect it, the potential difference is negative 2.04 volts, and when I connect it in parallel, it increases 2.06 because the new ammeter, since it has no resistance, it gets all the currents. So therefore, the 100 ohm resistor doesn't work, isn't in the circuit actually. So the resistance decreases, thus the current increases. Some values I calculated using Ohm's formula. Since there is no the precision is not enough, the readings would, the calculated values would be inaccurate. For experiment 4, we made an RC circuit. The light bulb slowly dims as the wire is connected, since the capacitor slowly charges. And then we use a charged capacitor to light the light bulb, and it goes very bright and then slowly dims again. So some questions. Initially, it has its maximum current, and it thus shines brightly, but then it decreases exponentially. Same as well for the discharging capacitor. There would be no current when the capacitor is drained. These are some time measurements I got for charging and discharging the capacitor. In experiment 5, we we measured some voltage differences in different time slots, and we drew the graph of natural log V divided by the initial voltage, which is 9, and we plot the graph, and we found that the slope of the graph is negative 0.141, and thus our measured RC would be 7.02 seconds. Some additional questions. If I were to do this lab in real life, the ammeter would have some resistance. Thus, our current would be larger because our current would be less because there's more resistance, and it should charge instantaneously. But since all our components, like the wires, have resistance, therefore some more time would be required to charge the capacitor. That is it, and thank you.